See, a spectroscopic instrument can resolve two nearby wavelengths lambda and lambda plus delta lambda if lambda by delta lambda is smaller than 8000. Okay. So as you know, the so in the atom, the hydrogen atom, E1, E2, E3 are the energy levels, and the diagram of the energy levels are exactly like this. The gap, see, E1 is how much? E1 happens to be minus 13.6 eV. E2 happens to be how much? E2 is minus 13.6 by 4, right? Minus 3.4 eV. And then E3, the next level, happens to be minus 1.51 eV. Next, E4 happens to be minus 0.85 eV. So as you see, as you increase the quantum number, the energy gap closes in, right? So if you go to higher energy levels, the gap decreases, the gap closes in, like this. They are very close. So that is why the resolving power or this resolution comes in. That means, so that is Balmer series, right? Balmer series happens where the electron jumps from the energy level E3 to E2. That means from shell 3 to shell 2. That is one line. Then shell 4 to shell 2, shell 5 to shell 2, shell 6 to shell 2, shell 7 to shell 2, shell 8 to shell 2, like this. I mean, it has to drop to level 2, right? That is what is Balmer series. Now, so approximately how many lines will be resolved by the instrument? So we can assume that approximately, say, n equal this n is the quantum number. So suppose n is the quantum number, principal quantum number, after which the lines cannot be resolved. That means, we suppose, say, one electron jumps from n to 2, say from n to 2, level 2. Suppose the wavelength is lambda. Now say from n plus 1 to 2, then the wavelength would be lesser, right? So suppose lambda minus delta lambda, right? Obviously, higher energy gap means lesser wavelength, lambda minus delta lambda. So we have to find this maximum value of n. After that, this gap is very less, delta lambda is very less. So the instrument cannot resolve beyond that. So let the maximum quantum number be n. Now see the solution, next page. See, this same thing is written. Till nth orbit the wavelengths can be resolved. So between nth and n plus 1th orbit the line cannot be resolved. So 1 upon lambda, here what we get, see, 1 upon lambda, right, equal to Rydberg constant 1 by 2 square minus 1 by n square. So 1 upon lambda minus delta lambda, right? R1 by R into 1 by 4 minus 1 by n plus 1 square. Now see, delta lambda by lambda should be less than 8000. So delta lambda by lambda by delta lambda less than 8000. So delta lambda by lambda should be greater than 1 upon 8000. So these equations 1 and 2, I have divided equation 1 by equation 2. So here what we get, lambda minus delta lambda divided by lambda is this. So from there you find out delta lambda by lambda. So you get such an expression, see, 32,000 greater than n square in bracket n square plus 2n minus 3 by 2n minus 1. So approximately this, so by trial error, approximately this comes out to be 40. They have, see in the question it is written approximately how many lines will be resolved. So it's around about 40. So you have to subtract 2 from 40 because it's Balmer series, right? So it jumps uh, till the second orbit. So you get how many lines? Approximately 38 lines. So as 40 minus 2 happens to be 38.